Okay, so this is a test of our inverse trig flipped lesson. We start with the function y is equal to the tangent of x. And a quick little sketch with x and y shows that the tangent graph passes through the origin. That would be passes through the origin, right about there. And there's a vertical tangent line at x is equal to pi over 2. And we have all of these branches repeated every pi interval. So 3 pi over 2, there's a branch. Another asymptote at x is negative pi by 2. There's a branch over here. And another asymptote at x is negative 3 pi over 2, and so forth. Okay. Notice that in this graph, you should be able to identify the zeros. The zeros occur at pi, 0, negative pi, and so forth. Well, obviously, the function passes a vertical line test. You know that all functions pass a vertical line test, so that if we were to move a vertical line anywhere, we can see that it intersects the graph only in one spot. That's sort of a duh. All functions pass the vertical line test. But does the tangent function pass a horizontal line test? That's an interesting question. So here's the horizontal line. And if we run that, obviously it intersects the graph in more than one spot. So the graph would fail the horizontal line test. Fail the horizontal line test. So let's write that down. Because y is equal to the tangent of x fails the horizontal line test, the function is not invertible. We cannot find an inverse for this function the way it stands. So what can we do? I suppose we can go ahead and note that unless we restrict the domain. And we saw this a little bit in chapter 1. So if we can restrict the domain and make the function one-to-one, or make it pass the horizontal line test, then we'll say the function is invertible. So the standard restriction is to look at only the branch that runs from negative pi over 2 to positive pi over 2. So on the interval negative pi by 2 to pi by 2, we do have one branch that would pass a horizontal line test if we exclude all the other parts of the tangent function. So we're going to erase all the other infinite number of branches and deal with only this section between negative pi by 2 and pi by 2. Okay, so now let's go ahead and find the inverse. Let me put up a new page here. We have y is the tangent of x with its restricted domain, and here's the graph running from x is negative pi by 2 to x is pi by 2. This is x, this is y. Okay, and there's our one branch. Now, to find the inverse graph, we have a sort of a recipe procedure. We swap x and y. So the x and y variables need to trade places. That gives us x is equal to the tangent of y. And then we have to solve this for y. We have to solve this equation for y. So let's say we have the tangent of y is equal to x. Let's recall what you did back in your project on right triangles. Let's suppose we had a right triangle, and I had an angle down here. I'll call it theta. And we had this side being 3 and this side being 1. And your task was to find theta. Think about how you did that on your project. You said, okay, I can look at the picture and we know that the tangent of theta is opposite over adjacent, 3 over 1. So the tangent of theta is 3, which means theta is the tan inverse of 3. And this was a number that you could find on your calculator if you needed to. And theta could be measured in degrees or radians. If theta was in degrees, you can go ahead and say approximately, you put the button in there, and you go ahead and get an answer. So we do know how to solve these equations for theta. We do know how to solve these equations for theta using the tan inverse idea. So if we have to solve this for y, back to our inverse trig function now, we have the tangent of y is x. So y is the tan inverse of x. Now, we can't do that on the calculator because we don't have a number here, but this does create a new function. This new function is what we're going to study in section 3.6. Y is the tan inverse of x. Sometimes some alternate notation is used, and we'll say y is the arc tan of x, and these are used interchangeably. Okay, let me give you the graph of the arctan of x. You can find this on your calculator. The graph, y1 is tan inverse of x. The tan inverse of x button is found right above the tan button. Here's the graph. Notice that it's very similar to the graph of the single branch of the tangent function, except now instead of having vertical asymptotes, it has horizontal asymptotes. And instead of having x is equal to pi over 2, this line becomes y is pi over 2, horizontal line, and y is negative pi by 2. Okay, so here's the graph of the arc tangent. Here's x, here's y. I'm going to stop that right now, and let's see if that comes out reasonably okay.